Hello, Professor Rad here for, I think this is our last video for Precalc. This is going to be our final analysis of a conic section, and boy, howdy, is it a doozy. So in the last video, we looked at an example where we had to complete a square, and we had a parabola. In this example, we will also have to complete a square, but it's not going to be a parabola. It's going to be something different. So let's go ahead and work through it. Once again, I have my list of all the different types of things we might need to identify. And here's our equation. 9x squared plus y squared plus 25 is 10y minus 36x. So right now, this equation is like a royal mess. We need to move pieces around so that we can start to get it more into the shape of what we want it to be. So the first thing that jumps out to me about this one is that we have both an x squared and a y squared. So that's going to indicate how I move stuff around. So because I have both an x being squared and a y being squared, that means I want to move anything that has a variable on it over to the left-hand side, and anything that does not have a variable over to the right-hand side. So I'm going to keep the 9x squared and the y squared on the left, but I'm going to subtract 25 to bring it to the right. And then I'm going to subtract 10y and add 36x to move it over to the left. So my first move is to get 9x squared plus y squared minus 10y plus 36x is equal to a negative 25. Okay, so I've moved all of those components around, so all the variables are on the left and the non-variables are on the right. And in fact, I'm going to move this around a little bit more. I'm going to group the x stuff together and the y stuff together, since it is in these formulas, right? So you usually have x minus h all lumped together and y minus k all lumped together. All right, so I'm giving myself some space to work in this equation. So I can tell at this point that this is going to be an ellipse. The reason that I can tell that is because I have both an x and a y being squared, and the coefficient of both is positive, right? So I have a positive coefficient to x squared and a positive coefficient to y squared. So that means I'm going to have two things being added. For a hyperbola, if one of these was negative, then I would have a hyperbola. So that's where we're going to be heading. But it's okay if you don't recognize that at this point. What's important is to recognize I've got some x's being squared and some y's being squared. So now I have to complete two squares. The y part is not too bad because the coefficient of y is 1, but the x has a coefficient of 9. So I'm actually going to start out by factoring that 9 out from the x terms only. Unfortunately for us, 9 goes into 36 4 times. And I am going to put a 1 here just to indicate that I did, have to pay attention to see if I needed to factor anything out of the y's. So because the coefficient of the x squared was a 9, I have to factor that out. And the coefficient of the y was a 1, so I'm going to write that as a 1 there. Now I have to complete the square. So to do that, I'm just paying attention to what's inside the parentheses here to start. So I have a plus 4. Half of 4 is 2. And then 2 squared, is 4. So same thing here, half of 10 is 5, and 5 squared is 25. So that tells me what gets added into those parentheses, but it's an equation. We have to maintain balance. So I have to add the same amount to the other side. However, be careful because we have a coefficient. So I didn't really add 4 here. I added 4 times 9, which is 36. And over here, I added 25 because of 25 times 1 is 25. Ooh, okay, so for the x stuff, my coefficient is 9. Half of 4 is 2, and it's a plus. So I have x plus 2 being squared, plus 1 times half of 10 is 5, and it's being subtracted. So we have y minus 5 being squared. What's nice over here is the two 25s cancel and I just get 36. Okay, so now we are almost done. We're actually in the same format we were in more or less when we started example 1 of analyzing a conic section. So now I have something squared plus something squared is a number. And to be in the format we like, we need this number to be 1. So I'm going to go ahead and divide both sides by 36. And that's going to give me x plus 2 squared over 4. Since 9 over 36 simplifies to 1/4. Y minus 5 squared over 36. And that's going to equal 1. So again, we divided everything by 36, and that brought us here. And then lastly, I'm going to write these as perfect squares. So square root of 4 is 2. So I'm going to write this as 2 squared. And the square root of 36 is 6. So I'm going to write this as 6 squared. Now, just for ease for this example, we've got numbers that factor and are perfect squares, like they're nice. But just a reminder, like if this had been like 39, right? Or even if this had been like 18, right? We could have divided both sides by 18, but the square root of 18 is not a perfect square. That's okay. I still would have written this as the square root of 18 squared. Okay, so just bear that in mind when you're doing this. Sometimes you get radicals being squared down here, and that's okay. You didn't do anything wrong necessarily if you get that. You might have done something wrong, but it's not a sign that you definitely did. So now that we have an ellipse, we've identified our format. We can very clearly see something plus something equals 1. We know we have 2 foci, 2 vertices, a center, but we don't need this parabola nonsense, and we don't need this hyperbola nonsense. So we can get rid of that stuff. Okay, we can figure out the center. That's HK. So remember, we're subtracting H and subtracting K. So H is a -2 and K is a +5. So our center is -2, +5. A is the larger of the two denominators and B is the smaller. So for an ellipse, that's not the case for hyperbola. Either one could be larger, but for an ellipse, A is the larger one. So A is going to be 6 and B is going to be 2. So A is 6 and B is 2. So that's the information we can glean directly from the equation. For the rest of the stuff, I'm going to need my graph to help me out. So let's go ahead and graph what we know. Our center is at -2, 5. So I'm going to plot my center at -2, 5. I hope I have enough space on this graph to graph this. If not, I'm going to be a little bit sad. Then Y is associated with A. So that means, oh, it's going to be a big vertical ellipse. So that means I have to go up 6 and down 6 for my vertices. So guys, I don't have enough space, do I? 1, 2, 3, 4. Oh no. Okay, I fixed it. I now have a bigger graphing space. So let's go ahead. A is 6, so I'm gonna have to go up and down 6 from the center. So let's go ahead. Point. Let's go up 6. 1, 2, 3, 4, 5, 6. Don't worry, I'm just going to send this to the back so we can see that point. Beautiful. And then I'm going to have to go down 6. So 1, 2, 3, 4, 5, and 6. There we go. Sweet. So if the 6 had been associated to the x in the formula, then I would have gone left and right by 6. Okay, so the equation does tell you whether you need to go up and down for the vertices or left and right. So since we plotted those vertices, let's go ahead and state the coordinates. So 9, 10, 11. So we are at -2, 11 and -2, -1. 2, -1. And -2, 11. There we go. And our major axis is therefore that vertical line running through them. So it's x equals -2. Minor axis will be y equals something. Okay, so let's go ahead and graph that, I guess. Here's our major axis of information. And then the minor axis runs perpendicular through the center. So I grab a horizontal line here. Through the center. So this is looking to be the line y equals 5. My minor axis is y equals 5. Now the minor axis is also, in this case, going to tell us how narrow of an ellipse we have. We have a pretty narrow ellipse because b is only equal to 2. So even though these points are not vertices, these are my helpful points that I'm going to want to graph. So I go to my center and I'm going to go over 2 spaces. So 2 to the right and then 1, 2 to the left. There we go. Those are all the points I'm going to need to graph my ellipse. Beautiful. So let's just go ahead and do that and make sure it passes through those points. Nice. So I think the only thing we're missing now is our foci and C. So we still have to graph the foci and we still have to solve for C. So on an ellipse, remember that on an ellipse, A, that distance from the center to the edge, is the largest distance. So that means we're going to have A squared is equal to B squared plus C squared, right? So that largest distance is what's equal to those smaller ones being added, all of them being squared, right? So I can plug in my A and my B and use that to solve for C. So A is 6. So 6 squared is 36. 2 squared is 4. So this is going to give me 32 is C squared. Oh, yuck. So 32 is 2 times 16. So that's going to give me 4 square root of 2. Oops. 4 root 2 is going to be C. Okay. So when I go to graph that, I'm starting at my center and I'm moving up 4 root 2 and I'm moving down 4 root 2. So starting at my center, I have the same x value because then I'm moving up 4 root 2 and then I'm moving down 4 root 2. This and that. Let's just go ahead and condense some space here. All right. Now to graph those, of course, we want a decimal approximation. So the square root of 32 is about 5.7, 5.66 or so. So about 5.7. So that tells me how far to count to graph C. So see, 1, 2, 3, 4, 5. Oh, very close to the edge here. So in fact, let me make this a little bit smaller. Of an X. That's 5.7 is really close. It's on the edge, man. It's getting pretty close there. All right, and then we can't really see those that well, so I'm just going to go ahead and change the color of that to something lighter. And let me send that backwards. And let's send that to back. There we go. So now we can kind of see those foci. That's really light. I can't see that at all. What's wrong with me here? Yeah, that's a little bit better. There we go. All right, so I've just changed the color of the major axis just so we can see those foci. They're pretty close, since 5.7 is really close to A, which was 6. But there we go. That's our beautiful ellipse. We don't need this arc because we're not doing a parabola or hyperbola. Sweet. And we've got all of our components here. So there you go. That's how we analyze the conic. This is probably as worse as it's going to get. The only way this example would get worse is if this y had a coefficient that wasn't 1 as well. So if this y had a coefficient of like -3, then this would be quite different. And the only other way it could get worse is if these were not perfect squares, right? So if this hadn't been 36, if this had been like 18, that might be a little bit nasty. But the process is still going to be the same. So yeah, so I hope this video helped you to analyze conic section, in this case an ellipse. There is no next video for this course, so I hope you found the series helpful, and yeah, feel free to poke around some of the other videos on my site. We've got some for statistics and linear algebra, which might be interesting if you're interested in that kind of stuff. So I hope you have a fantastic day, and I hope to see you again. Bye.